Pluto, once viewed as a far-off and confounding minor planet, was initially delegated an individual from our nearby planet group. However, pivotal discoveries from prominent astrophysicists, such as Neil deGrasse Tyson and Michio Kaku, have pushed Pluto back into the spotlight. They shared an amazing hypothesis proposing that Pluto could be on a crash course with Neptune. But how can this be? And what might the results of such a grandiose crash ever be? Are we witnessing an uncommon, huge event, or is there something else to this looming disaster? Join us as we investigate the potential results of a Pluto-Neptune impact. Once viewed as an obvious planet, yet later downgraded to a dwarf planet because of its unique orbit, Pluto remains an object of serious interest and study in mainstream science. Ongoing conjectures from leading experts show that Pluto's orbit is dangerously close to that of Neptune, prompting astrophysicists Neil deGrasse Tyson and Michio Kaku to raise alarms about the potential for a devastating crash between these two heavenly bodies, a situation that could represent a significant danger to Earth. But how can this even be within the realm of possibility? Pluto's journey around the Sun is unlike that of any other planet in our solar system, requiring a shocking 248 years to complete a single orbit. Since its discovery in 1930, it has yet to complete even one full revolution. Yet Pluto's orbital capriciousness doesn't end there. Its orbit is highly elliptical, distinctly standing out from the almost circular paths of other planets. Adding another layer of idiosyncrasy is the tilt of Pluto's orbit, calculated to be 17 degrees to the ecliptic plane. This means Pluto's path is much steeper compared to that of the other planets. The combination of unpredictability and steep tilt makes Pluto's orbit a complex puzzle. Perhaps the most fascinating part of Pluto's orbit is its interaction with Neptune's. For roughly 20 years in each orbit, Pluto comes closer to the Sun than Neptune. This goes against what we might expect from their relative positions in the solar system. Naturally, this leads to the question, why hasn't Pluto crashed into Neptune? The answer lies in the gravitational influence of other planets. Pluto's unique orbital behavior was first examined soon after its discovery. Cosmologists were initially puzzled by its unusual path. Unlike other planets whose orbits lie relatively close to the ecliptic plane, Pluto's path is inclined and elliptical. The mystery grew when it was realized that Pluto's orbit does indeed cross Neptune's. The fact that Pluto's orbit remains stable despite these apparent clashes demonstrates the complexities of celestial mechanics. The study of this phenomenon involves the three-body problem, which seeks to understand the gravitational interactions between three bodies in space, such as Pluto, Neptune, and the Sun. This is similar to predicting the movements of these bodies based on their initial positions and the gravitational forces they exert on one another. In Pluto's case, this issue highlights how Pluto's orbit, Neptune's path, and the Sun's gravity work together in a complex manner. Terms like asymptotic libration, scope libration, and the VSK oscillation help explain this. Astrophysicists have confirmed that the phenomenon of libration is crucial in maintaining orbital stability between Pluto and Neptune. Libration ensures that when Pluto crosses Neptune's orbit, their relative positions are always at least 90 degrees apart, preventing a collision. Scope libration describes the upward movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other large planet, it is positioned above their orbital plane, providing extra protection from a potential impact. Another key factor in maintaining Pluto's stability is the VSK oscillation, named after scientists V. Appleby, L.V., and Key, who studied the gravitational effects between three objects in space. This concept explains how Pluto's, Neptune's, and the Sun's gravitational interactions affect Pluto's orbit. The VSK oscillation helps us understand why Pluto's path around the Sun is so unusual, and despite seeming turbulent, it actually maintains Pluto's orbit for an extraordinarily long time. This oscillation shows that even in seemingly chaotic systems, there are underlying patterns that help maintain stability. All of these factors, libration, scope libration, and the VSK oscillation, help ensure that Pluto's orbit remains stable, preventing a collision with Neptune. This exchange of forces shows how complex celestial mechanics can stabilize even the most seemingly irregular paths. Understanding the three-body problem is essential for unraveling the dynamics of these orbits, not only for Pluto but also for other distant objects in our solar system. Numerical simulations from the late 1980s revealed that while Pluto's orbit is stable for now, it displays slight variations that could lead to dramatic changes over thousands of years. These simulations also showed how the gravitational forces of giant planets like Neptune, Jupiter, and Saturn contribute to stabilizing Pluto's path. In fact, Pluto has a unique relationship with Neptune, where Pluto completes 2 orbits around the Sun for every 3 orbits Neptune makes. This resonance maintains the stability of Pluto's orbit. However, Neptune isn't the only planet influencing Pluto's path. Jupiter, with its massive gravitational pull, also plays an important role in safeguarding Pluto's orbit. Saturn's influence further adds to this cosmic stability. Simulations demonstrate that Jupiter alone has enough gravitational power to keep Pluto's orbit steady over incredibly long timescales, potentially billions of years. It's as if Neptune, Jupiter, and Saturn are working together to prevent Pluto from facing any risks in space. These gravitational interactions are essential for maintaining the overall stability of the solar system, preventing chaos that could arise from bodies like Pluto crashing into others or being ejected from their orbits. The significance of these gravitational forces extends beyond Pluto and Neptune. The study of these interactions provides insight into the larger cosmic order, showing how even the smallest forces can have far-reaching consequences on the stability and motion of celestial bodies. Without these stabilizing forces, the solar system would likely be a much wilder place, with objects like Pluto potentially crashing into other planets or being ejected from their orbits, leading to erratic outcomes for other bodies in the solar system. Given these complex and stabilizing forces, why are scientists like Neil deGrasse Tyson raising concerns now about a potential Pluto-Neptune impact? A notable astrophysicist is popular for his work in the renaming of Pluto as a dwarf planet, and his perspectives on Pluto's orbital elements continue to develop as new data becomes available. Tyson contends that the renaming of Pluto was not a minimization but rather a vital change, as our understanding of the local solar system has evolved. He views Pluto's bizarre orbit and interactions with Neptune from the perspective of ongoing scientific discovery, recognizing the inherent volatility of space. While Pluto's orbit is stable at present, Tyson acknowledges that future changes in gravitational forces, whether from the Sun, other planets, or unknown forces, could lead to unexpected changes. This uncertainty serves as a reminder that even systems that seem stable today are subject to future developments. Tyson's warning about the possibility of a Pluto-Neptune collision highlights the evolving nature of our understanding of celestial mechanics. While such a collision may not occur for billions of years, it underscores the importance of continuous research and adjusting our models as new discoveries are made. The study of Pluto's orbit is fundamental to understanding the broader forces that govern the solar system. Tyson's emphasis on the uncertainties of the future calls for continued observation and study, allowing scientists to refine our understanding of how gravitational forces and interactions shape the fate of planets and dwarf planets alike. As we continue to study Pluto's path and its potential for future change, we are reminded of the unpredictable nature of space. Despite the current stability of Pluto's orbit, its future remains uncertain, and the possibility of a collision with Neptune or even a dramatic shift in its trajectory remains a distant yet fascinating possibility. As we delve deeper into Pluto, our solar system, and the universe itself, we will continue to refine our understanding of how celestial mechanics affect the behavior of planets and dwarf planets within our vast expanse. Pluto's future may still seem uncertain, but with each new study, we gain further insights into how our solar system operates. The delicate cosmic dance between planets like Neptune and Pluto emphasizes the sheer complexity and wonder of the universe. Although Pluto's orbit might remain stable for millions of years, there is always the potential for change hidden within the chaotic forces of space. Pluto's path through the universe is far from simple. Despite its current stability as a dwarf planet, it offers a striking example of the complexities of celestial mechanics and the forces that govern the movements of bodies in the solar system. The fact that Pluto's orbit intersects with Neptune's without causing a catastrophic collision challenges our conventional assumptions. This intriguing case invites further investigation into how various forces coordinate to prevent space objects from colliding with one another. While Neptune's gravity is often seen as a major influence on Pluto's orbit, interactions with all the nearby planets, especially the large gas giants, play a crucial role in stabilizing Pluto's path. Jupiter, with its massive gravitational pull, plays a pivotal role in this gravitational cooperation, helping maintain the stability of smaller and more erratic objects located in the outer reaches of the solar system. Saturn, too, with its vast rings and gravitational influence, contributes to the overall stability of planetary orbits. These giant planets act as cosmic shepherds, keeping Pluto on its steady course despite the eccentricities of its orbit. In addition to the gravitational forces exerted by the planets, the Sun's gravity remains the most crucial force guiding the orbits of all objects within the solar system, including Pluto and Neptune. The Sun's power establishes the overall structure of planetary orbits and the general stability of the entire solar system. However, the Sun itself is far from static. It goes through various cycles of activity, such as solar flares and fluctuations in its magnetic field. These changes, though subtle over short periods, could influence the orbits of distant bodies like Pluto and may, over incredibly long timescales, alter how Pluto and Neptune interact with one another. In the distant future, the ongoing study of Pluto's orbit not only helps us understand the current configuration of the solar system but also provides valuable insights into the cycles that shape the evolution of planetary systems over time. Although Pluto is currently safe from a direct collision with Neptune, the dynamic nature of the solar system means that no orbit is permanently fixed. There are forces beyond gravity that can influence the movement of celestial bodies, and even tiny perturbations in planetary orbits could lead to larger changes down the line. This turbulent motion is one of the defining characteristics of the universe, constantly evolving, shifting, and presenting new challenges for astronomers to unravel. The possibility of a Pluto-Neptune collision, though highly unlikely in the short term, illustrates the inherent unpredictability of stable systems over long periods. Studying the orbits of objects like Pluto allows scientists to grasp not only the current layout of our solar system but also the factors that could eventually reshape it. Programmatic studies of Pluto's orbit have shown that even small changes in initial conditions can significantly affect its future trajectory. These tiny alterations, when amplified over millions or even billions of years, could potentially bring Pluto closer to Neptune's orbit. This raises intriguing questions about whether other dwarf planets or objects beyond Neptune may eventually experience similar gravitational encounters with larger planets like Neptune or even Jupiter. The outer regions of our solar system are still largely unexplored, and many objects remain only marginally studied. The complex interactions between these bodies offer a glimpse into the forces that govern orbital stability and may ultimately determine the fate of the solar system. The future of Pluto and other objects in the outer solar system depends on a variety of factors: gravitational, physical, and perhaps even unknown influences that scientists are just beginning to fully understand. The complexities of planetary motion offer a fascinating glimpse into the long-term fate of our solar system, a future where even the most seemingly stable systems can be reshaped by the forces of nature. In conclusion, while Pluto's orbit is expected to remain stable for millions of years to come, the possibility of change driven by chaotic forces within the universe cannot be ruled out. The study of Pluto's trajectory offers important lessons not only about the current state of our solar system but also about the mechanisms that might shape its future. By continuing to study Pluto and its interactions with Neptune, scientists gain a clearer understanding of the broader forces at play and what these forces could mean for the solar system in the distant future.